started, making sure that your tool chain is set up, making sure that all the services that you're going to be working with are all ready, and basically baking your first unikernel using the Craft toolchain. So without further ado, I'm just going to share my screen, share this terminal. Hopefully you can follow along. I'll explain basically everything that I'm doing, sort of as much detail as I can. If you have any questions, please just ask. This is meant to be a super interactive. It's meant to be easygoing. So if you have worries, concerns, or feel like I've missed something, or you don't understand what's happening, just say, we just shout. It's absolutely okay. We have plenty of time here to work through everything. And if you're also maybe thinking, I didn't understand that, maybe other people are experiencing that same question as well. So it's absolutely okay. So Craft is a Python-based tool, and it is a tool that allows us to download the remote repositories that makes up Unicraft. And so you can think of Craft as a package manager, just like apt-get, just like if you have a Mac Brew or Windows Choco, or if you're Yum, if you're on CentOS, or what's the one for Arch Linux? Anyway, you can download different repositories from Craft, and when you get different repositories, you use them to create your application. And so you have to think of a Unicraft unikernel, if we think of the most basic thing as a unikernel, as an application that has libraries. And the application has these dependencies, and so requires to get the libraries remotely. And the way that it essentially works is that there are sort of three core type of libraries. We have the core library, which is the internal kernel that is Unicraft, the Unicraft source code. It basically is the stitching and glue that makes the rest of things possible. We then have external libraries. These are library dependencies of your application. If we think of a simple application such as Nginx or Redis, it likely needs to do threading, and there is a library. So some wonderful people have built a library to do threading. So we can use that remote library for threading, and we can pull it in, and we can use it for our application. We also need a library to do network stacks and to communicate TCP/IP and all the wonderful things that you can do over a network, etc., etc., etc. So we have different libraries, and we have applications, and we also have platforms. Now, platform is a sort of a monitor, a way to oversee the runtime of an application. This is once it's built, but once it's built, it needs to be able to communicate directly with this platform. The same also goes for architectures, right? You want to be able to target a very specific hardware architecture, a CPU, right? Whether that's Intel x86, whether that's ARM, whatever that might be. And all these different components put together basically make a unikernel. And a unikernel, in its very precise definition, is a single specialized kernel, an application, sort of bundled together. You compile all these components together, these different libraries, and at the end you get an image, a final binary that you can then run on that target application, with that target platform, and with the libraries and application that work directly together. So basically, to get started, we follow the installation process for Craft, right? So Craft is our main tool here, and you can find the repo at this unicraft/craft.git, and this is basically it, right? So you go here and we install the dependencies. So I've already installed the dependencies. It's just sort of lists. I can paste them here. And hold on. Let me just copy paste so you can see, because I feel like you can only see my screen and not other. So you have all these other dependencies. These are dependencies that are needed to make Craft work. And Craft is written in Python, so it needs Python installed. And you also have all these additional sort of things that are needed, right? So we got Build Essential here, for instance. Build Essential is part of the GCC toolchain. It contains Make. It contains a whole bunch of essential build tools. We've got ncursors here. This is a library that's used to do terminal manipulation, like a terminal user interface. We use YAML. We've got Flex and Bison that are part of GCC. Git, of course, because a lot of the libraries that we use that Craft retrieves are Git-based, wget. Same purpose, to download things remotely. Unzip, because we download zip files. And UUID, because we generate unique IDs, etc. So once these are installed, we can then basically clone this repository and install it and use it. So we can clone, staging. You don't have to do this, it's the default. So if you do see it, don't worry, you can just do git hub unicraft.craft.git. Hopefully it should just clone. Okay, cool. You can see it's downloaded in this folder. Downloads a whole bunch of history. We can then cd into craft, and then we can do this pip3 install-e. So this should, install craft onto your machine. This is based on having had the dependencies installed as well. And if it likes to work, come on. Oh, yep. Hello. Okay. Cool. Okay. So hopefully, once that's run, you should just be able to do craft and then -h. Okay, there we go. So this is craft sort of installed, and you've got a command line tool now, and we can use it to retrieve all these packages and remote libraries and stuff like this. So the next thing that we want to do is go to GitHub, and we want to retrieve a token. So the token is a personal access token. Can you see this part of this one? So I'm going to change, hold on. Okay, so we go into settings here. So my wonderful profile. Go to developer settings, personal access tokens, and then we generate a new token. And then I have to enter my password. Hold on.
You'll have to do this yourself, unfortunately, because of the rate limit. So you're going. I think we announced that in the session, but you'll have to do that. So
yes, you'll need to generate this, and this URL to get you to this exact page will be available. And all you have to do is, I don't know, give it a name, give it an expiration date. I'm just going to give it 7 days. All you need is public repo. And this is the only thing you need to click. Click generate token. And it should pop up here. You should get a unique token. And then I can switch back to the other. Change windows.
Excuse me, Alexander.
Hi.
Could you just show me again the permissions that I have to have selected?
Yes, it's public repo. So if you go to personal access tokens.
Alex, we don't see your web browser, so if you wanted to show that, it's currently only your command line, your terminal.
Okay. I'll switch back. Yeah, for some reason I can't share my exact screen, so let's change windows. Okay, so generate new token. And then public repo here. Does this answer your question?
Yes.
Perfect. Okay, let's change Windows.
So once again, any sort of issues you have, if there's something unclear, please raise raise a question. So it's perfectly fine. Thanks, Alex, for this.
No problem. So the next step here is to tell Craft to use this token by setting an environmental variable. And we do this by calling export UK Craft GitHub token equals, and then that's the URL, and then the exact unique ID that you got here, right? So you can see here it should start with GHP underscore and then some nonsense here. So you should be able to just set this, you just run it. Now it's saved into your environmental variables, which means that Craft can now see it. So the next thing we want to do, we can exit this directory, we can clear, Craft list update. So what this command will do, Craft list update, is it will use this GitHub access token, and it will go to GitHub, and it will retrieve the list of all the repositories that are on Unicraft's GitHub organization. So it will find. Okay. So if you do see this, this is because we have not set a .craftrc file, and we can do this by so if you copy. So hold on. Inside of Craft, we have this craftrc file, which I should actually also go into because it's quite an important file. Craftrc, just like bashrc or zshrc, is a file that Craft references for basic configuration. So if we cat this file, you'll see that it contains information about where it should go, what its default platform should be, etc. So I'm going to copy this file. Let's see, yeah, .rc. I'm going to save it to my home directory. So just in my home directory, I have lots of files, the same as like a bashrc. I've got a zhrc file. Apparently I can't edit that file. Never mind. Okay. So let's edit this file, the .rc file. It's the same one as before. I'm going to put Firefox origin true. And then it goes to this list. So you can see here it goes to GitHub, it goes to the Unicraft organization, and it retrieves platforms, applications, and libraries. So if you've ever edited an apt remote repository, this is the same kind of principle, where you're adding a remote repository there. Okay, so I can then do Craft list update, hopefully. Cursor must be straight or whatever. Okay. Okay. Here we go. Okay. Basically, what I just did is I jumped into a container environment, and I will jump into this a little bit later. But the basic principle is that once you have it installed, you should be able to retrieve the remote list of repositories. And you should see here that these are all found via that same craftrc file. So we've got a wildcard here, and it's just gone to the GitHub API, and it's pulled out all the apps and all the libraries. And so you should see a list like this, and then you should be able to do craft list update, craft list. Right? And craft list will then show you everything that is basically supported by Unicraft at this point, including the major versions that are released, the major platforms, all the libraries, and all the applications. Now, the color output here that you see is a small indication of what's actually installed on your on your computer, and it is. You can think of it as kind of being installed. It's more about it's being Git cloned. So if it's red, it's not been cloned to your local computer. So to get started building a application, there's a very seamless command that you can use that's basically packaging a lot of the configuration commands and steps like this into one whole bundle. And that's Craft Up. Craft Up is designed to basically quick start an application that you would like to build as a Unicraft unikernel. It configures, builds, and runs applications for selected architectures and platforms. And so we can use it to download, to configure, and to run an application. So let's try with the Hello World application. The Hello World application is just the standard boilerplate for any go-to new programming language or environment. And it's basically a program that's written in C, and it essentially runs, it boots, and it prints the words Hello World. And we can modify it from at this point. So if we do craft up, hello world. At staging, we need T, the template. We can then also choose a directory that we wanted to get it to. So we can do apps, and we can do hello world. And so this is the path that we would like to run, or like to save the sources for the hello world. So we should just be able to do this. I put at staging, and you can think of the at as the same way as we think of a version, right? So if there was a version, we could also do 0.5. Staging is the latest and greatest version of Unicraft, and you'll see a lot of it at the moment as Unicraft is currently and continuously being developed. It's a branch that many people use simply because it's well tested, even though it's not stable, but contains the latest features. And you can tell Craft in any moment where you want it to use a particular version that you can use staging. You can also say stable. It's the same as picking the latest version. In this case, the latest version is 0.5. But staging contains a lot of new features that have not necessarily been released yet, but have still been tested. So, if we run Craft up and choose this, it should download the application for Hello World and the version of Unicraft. It then starts to configure, and we'll get into the basic premise of what this step is a little bit later. It then starts to retrieve, and then it starts to build the unikernel itself. So here we are seeing all the different individual files for the unikernel being compiled, being linked, and then finally being booted. So here we just saw a full compilation process, a full boot, including, if I scroll up a little bit, oh, it's gone. No mind. I think it's just this terminal. The boot process, right? It booted, it wrote hello, the Unicraft banner, which we can configure as we wish, etc. So what this did for us is, if we recap, go to the remote versions of the Unicraft repositories. We listed them. It then retrieved the relevant ones for the Hello World application, which it understood and existed. It then downloaded the dependencies for the Hello World application. It then configured it, built it, and then booted it. Okay, and now let's just go through all those individual steps. So when we retrieved everything, we set up a sort of little bit of a small directory structure in our place. So in this structure, I've set the craft.rc file, and the craft.rc file is set using the environmental variable craft.rc, wherever that is. Here we go. So craft.rc is set to this directory here. It contains the same information I showed you before. So it contains where it will go. So if you have built your own library or application, you can update this list. And when you run craft list update, it will go to the remote place and it will retrieve it. Okay, the next thing it did was it created a directory structure for us based on our request. It contains a apps directory, artist directory, libs directory, class directory, and Unicraft directory. Inside of apps, we have the Hello World application. Inside of the libs, we didn't download any dependencies, so we won't have anything there. And inside of the Unicraft directory, we'll have the source code of Unicraft itself. And so this is the main repository that you will see if you ever go to, if you click on GitHub. So it's the one that's located at github.com/unicraft/unicraft. So this is that's that source code. And this is the sort of core code that, as I said earlier, basically glues everything together. Let's go inside of the Hello World application. Apps, Hello World. Okay. So here we are inside of the Hello World application. And the directory structure here basically contains a number of core files that are important for creating any application inside of Unicraft itself. We have obviously the main.c file, which is the C file that printed Hello World. We do that. You can see it. Maybe it looks a bit better if I do this one. Apps, Hello World. And then we got C here. Yep, so here's just a C file. There's where I printed Hello World. We can modify this and we can rebuild it and we can boot it, and that's great. But also we have the craft.yaml file. The craft.yaml file is a file which has been modified because you can see all these bits here, but that's because it's been modified by Craft itself. it basically is a specification file. It tells Craft how to build an application. In this case, it starts with a specification version. Craft understands this as understanding how to parse the rest of the file. We have a name of the application. We have a version of the application of Unicraft. So Unicraft's core, we can say which version we want. We can provide some other additional features here. We have a number of different platform target combinations. It seems to have added a lot here. We have a list of library dependencies, volumes, which you can think of as a Docker container in the sense that you attach a volume, a file system of some sense. It's using the same terminology here, but it's a bit different. And then also the networking setup. We can configure all of this in this same file. Okay, so how do we configure one of these applications? So once we've sort of downloaded everything and it's there, we can configure the application. And so let me go back to the terminal. I have to quickly change something real quick. So this is a current, it's not a bug, it is a change that's currently a PR that our architect needs to approve. And so you shouldn't have to worry about this, but basically, once we have an application downloaded, we can run Craft menu config. Craft menu config is a terminal user interface application that allows us to select different options for the build of the unikernel itself. And it looks a little bit like this. Apart from the stylized orange, it's basically something that you can use with the up, down, left, or right arrows. And you can choose everything from architecture, platform, library, particular build options, and options of the application itself. So let's just go through what this menu kind of looks like and what some of these options mean. For architecture, when we want to configure something, we want to choose which architecture we would like to go for. In this case, x86, because I'm running on an x86 machine. Other supported architectures are ARM v8 or ARM v7. We've got some processor optimizations, whether it's for generic or whether it's specific. We can change things here. We've got platform selection. Here we have actually sort of almost like a checkbox system where we can choose different platforms we would like to target. The whole notion of Unicraft is that you can build your application once and target multiple applications. Here we are targeting KVM. KVM is the kernel virtual machine for Linux. It allows us to run small specialized virtual machine, or any virtual machine in this case, but Unicraft targets KVM, so we can boot a Unicraft unikernel in its own segmented, isolated memory address space. It has its own core. If we decide to give it a core, it can run by itself on KVM. And there are, of course, some KVM options if you dive deeper just by hitting enter. So here we can select different things. Here, more interestingly, is we have library configuration. Here is the sort of remote dependencies that Craft can pull, including internal kernel options provided by Unicraft. So we have a number of different libraries that we can add to our application, or if an application requires them, that we can then select them here. And we then can change a number of different individual options inside the library itself. So for the unikernel application that prints Hello World, we have a few dependencies. We have nolibc, a standard C library that has basically providing some POSIX compliancy. We have a memory allocator. We have a body implementation of a memory allocator. We have something called argparse, which parses arguments provided to the kernel. If you can think of any application that is a terminal-based application, you provided command line arguments. Argparse is Unicraft's internal one, so you can provide it some arguments. We'll get a little bit later on to some of them. For instance, you can say which static IP address you would like, and argparse passes that. We of course need to boot. UK boot provides some booting functionality. We've got some debug options. These are quite important, and I will get into this in a second, but I'm just going to go through the rest of the list. Timing functions and VFS core. VFS core being the interface between actually talking to mounted things that you have as a virtual file system and Unicraft itself. One of the probably the most enabled options that I go to immediately is inside of UK debug. UK debug basically allows us to print additional kernel messages during the boot. So to show you how you can then reconfigure your unikernel, let's actually change some options. So when we do the make menu config, or when we run a tool called craft configure, we basically set some of these. So these are all set. You can see there's a little asterisk here. It sets something. This is enabled, whereas this is disabled. So let's enable debug messages globally. Let's change to show all types of messages. I'm just sort of pressing up, down, and pressing enter and pressing space to enable things. Let's change the color of the output so that we actually get some nice pretty colors. Yeah, okay, that seems good. Let's save, let's press OK, exit, and then just exit again, exit again, exit again. Okay, cool. So what did that do? We just changed some particular options inside of the unikernel. And what it did was it saved and changed a file called the .config file. So if we go back to our application, we have this .config file. This .config file has just been set with new options, and you can see these are more or less the options we set. So somewhere in here, it will tell us that we set, for instance, the colored output. And so this is set to white. And so this option that we found through the make menu config, the terminal user interface that we just saw, set this to white. And also save the .old, so this was the previous version of that same file, and the colored output will probably be set to not set here. Yeah, here we go. So we can have a little bit of a history to see what happened. We can ignore these, go away. Awesome. Okay, cool. So let's get back to building. So once you've configured your application, either through the make menu config or this craft menu config that you just saw here, you can also do it through configure. Configure is the same process, it's just a very explicit way of doing the same thing. So, if I knew the exact name of the option that was in question here, so we go back to opening this .config. So this is the option that was in question. If I knew I wanted this, or I knew the set of target applications, I can just run configure, and I can be like, yes, that one, right? And it will just set it. So this is just more of a sort of systematic way of setting a particular option when you want to do your configuration step. If you run craft configure without anything, it will just sort of set sensible defaults. Some of these sensible defaults are set inside of the craft.yaml file. Others are just automatically figured out because they're enabled by default because of the way that Unicraft is built. There are some things that you can't turn off because they have dependencies. And so running craft configure will kind of figure out the minimal set of configuration that is used to actually not necessarily run the application, but to at least configure it. Okay, so we've configured our application. The next step that we saw in the craft up stage was to build. So we've done craft build. Craft build does a number of internal steps for us. It fetches the remote sources, it prepares them, and then it runs the actual compilation of the various files. And so we've just changed a number of options inside of craft. We've reconfigured it, and as a result, it's built us new binaries and it recompiled relevant files for us. When we look at the directory that we have for this application, we have a build folder here. Build is a new folder that is created by the Unicraft build system and by Craft, and contains all of the intermediary object files that you see up here, all these .os, all these linked objects as well. It also includes the final binary that is the unikernel, this one. So when you see scstrip, this is the binary that has been built, and Craft kind of tries to help you out and says, look, here it is. So if we do ls on this directory, there's a lot of the object files, a lot of folders, etc., but somewhere in here we are, is that binary. That's the one that we can run. So we've built it. We have a unikernel, that's great. Craft again comes with a utility command you can use to essentially bootstrap the whole instantiation of the unikernel for you, and that's just craft run. Craft run is attempting to intelligently boot the unikernel. It looks at what you've got, looks at your system, and sees if it can match up all the things. And so this system that I'm running on right now, it's x86 and it has KVM. I've built an x86 and a KVM image, and it will try and run those. So we do craft run, hopefully it should boot, and actually here we go, we have a lot of new debugging information that we've just outputted, including what we saw originally, which was the Powered by Unicraft banner, and of course the hello world that we saw in the main.c file. But of course, if you're building unikernels, you're getting really sort of into the nitty-gritty, sometimes you want to enable a debug output, or at least a more verbose output where you can see some information such as this. This is great. It looks like it's working. That's fantastic. Okay, cool. So, what are the next steps? Let's go through a little bit more detail of the configuration steps and what you might see in a craft YAML file for maybe a little bit of more advanced application. And this is basically, we're stepping a little bit away from the hello world, and we're going to move on to another application. So if you craft lists, we should see now that Unicraft, it was I think orange before, now it's a light yellow, thanks to my feed it's not green, but it's been downloaded. We also have one application, the hello world application, and this is saved here. We can give some more information out from craft lists. We can do -d to show local, -i to show what's installed, and it should just show us these two. Cool. So this is the paths where they're saved, and this is what's sort of on the system. So let's move on to another application, one that's a little bit more advanced. It has one more library, and that's HTTP reply. HTTP reply is a simple application that replies to HTTP requests. So let's go back, go to apps, go craft, list. Okay, so we had craft up before. Craft up was a nice sort of getting started command that allows us to pull, configure, build, and then run the unikernel from first principles, right? But another way to do this manually is to do craft list pull. Craft list pull pulls a particular target, whether that's a library or an application or the Unicraft core, and saves it in the right place. So we have craft list pull, and we want to get the HTTP reply application. And again, I wanted that staging because I want the bleeding edge. I want everything that's nice and new. So if we do craft list pull, it should go to the remote repository and download its dependencies. Okay, so you can see here that the HTTP reply app has indeed downloaded. This is actually the version that you see here is the latest git commit SHA of staging. And it also has downloaded liblweb. So we have our first library here, and it's pulled it at 0.5. So if we close this terminal and we browse our directories, in this whole structure here, we should have a new folder called HTTP reply. This is our app, and it should contain all the source code. Wonderful. Okay, great. So let's look at the craft file. This is the craft file for the HTTP reply application. In addition to saying the specification, of course, that I mentioned earlier, and the name, we have some additional information about the Unicraft core. So it's asking for the 0.5 of the core. And in addition to this, it's telling us some configuration options that need to be set for the Unicraft core. So we have this nolibc that needs to be set to Y. We need a scheduler. This is what this libukschedule means. And we want the cooperative scheduler. This is what these options are actually telling us. We actually have only one target architecture platform combination, and that is x86 on KVM. Great, that's the host that I'm on, so we can run it. And it has actually now set a library. So we have lwip as a library dependency. So the HTTP reply application has essentially two dependencies, Unicraft core, of course, and lwip. lwip is basically short for lightweight IP. It is a networking stack. It provides us TCP, as you can see here, some socket interfaces, a way to understand IP addressing in IPv4, a way to do DHCP, which is a way to retrieve automatic IP addresses from a DHCP server. Your laptop, your computer will do this if you have a router. So it has some networking functionality, which is great, which is something that we can now actually play with other than see the words hello world. So when we retrieved HTTP reply, and you saw it got HTTP reply first, it read the craft file this file here, and saw it had a dependency and downloaded it. It downloaded lwip at 0.5. So it put it inside the libs folder. And here we have lwip. This is the lwip wrapper library for Unicraft, and basically pulls the remote source code for lwip and exposes a number of internal interfaces to Unicraft. We want to use this to actually do networking. So let's build it. Let's see what we can do. Okay, so let's go to HTTP reply, to the screen. Okay, that's definitely the directory. Okay, so let's do proc configure. When we want proc configure, it should just use the sensible default options that it found before, and actually made a few modifications that you saw to this file here that you saw. You can see just, so the green here are like git new lines. Craft just tries to be as strict as possible. It was missing this, which is okay. It doesn't have any volumes and it doesn't have any networks. Not to worry. Okay, back to the terminal. So we have configured this application. Configuring has set all of those configuration options. They are the ones that are about to be built. It is set for the particular target that is the architecture and that is the platform. So we can basically move on to the next step, and that's to build. So we do craft build. It should hopefully take the configuration options that has been set in the .config file. It is now downloading a remote dependency. This is the source code for lwip. This is why we need to install unzip. And it's busy downloading it. It's patching it. These are we'll get into what patching means a little bit later on in the course. It's then now compiling all the relevant source code files for the Unicraft core and for lwip itself. So it's busy compiling libc, the allocation, memory allocator, the body allocator implementation, some scheduling stuff, cooperative scheduling, the interface to do virtual file systems, some additional stuff, and there's some lwip. You can see lib lwip. And so these are all the file dependencies written in C for lwip. And here we go, it's being successful, and it's built our binary. Here we are, once again, with a build folder, and inside of the build folder, we can see all the object files. When we scroll to the top, we should be able to see our final binary. So here it is. And it is 0.5 MB. So this program, HTTP reply, if we go into the source code of HTTP reply, it should just do one thing and one thing only, and that's reply to requests, basically providing a HTTP response saying it works. So if we make a request to it, that'd be great. So let's try and boot it. So I'm going to try craft run, but this won't necessarily work. We need some more arguments. Okay, well, it's running, but we definitely won't be able to talk to it because we don't know its IP and we don't know where it's actually running. So let's cut it. What we need to do to it is provide it command line arguments using the command line argument parsing library that I showed you before, to actually give it an IP address. Or we actually attach a DHCP server and it automatically negotiates an IP address, and then we can actually do this. So I need to actually exit this container and attach the netcap. Like this. I'll get into a little bit of detail of what this is in a second. Oh. Okay, I do want to start. Never mind. Sorry. Yeah. Okay. Oops. Okay. So our type IPA is not installed. So we have to install apt install bridge utils. Did that install? Cool. And then we need to install net tools. Cool. Cool. So if I type ifconfig, I should get all my network devices, and I should be able to create a bridge now. These were the two commands that I just installed. So ifconfig and brctl. We're going to create a bridge A bridge is a networking sort of device. It's a virtual bridge. We can attach interfaces to it, including a virtual machine. And then we, as ourselves, as the host, can be able to talk to it. So if we do brctl, we can add a bridge and we pull this prop 0. So I do if config. We should be able to see. brctl. I should be able to see. Yeah, prop 0. Okay, so if config. So this is now created the virtual bridge. We want to give it an IP address, a bridge IP address, which is the gateway IP address. I always pick 172.88.0.1. And then if we do ifconfig prop 0 up, and if I didn't type ifconfig, we should now see we have a new interface. This is now an interface that I can talk to as my host, and a unikernel can be attached to, and we can basically give them an IP address. Okay, so great. So we want to run our unikernel, and we want to attach it to this bridge, and we want to basically give it an IP address so that we can talk to it. We want to see that message that we saw over here, the one that says that it works. Okay, so what do? We can use craft run again, but we can give it some command line arguments that basically provide us with the ability to instantiate it with a IP address. So we do prop run. The prop run comes with a number of different flags. The first that we want to do is bridge, and we want to give it access. We want to tell it that we want to use the bridge. So prop 0 was the bridge that we just created. We then want to pass it args. So args are going to be passed directly to the unikernel itself. You think of a unikernel, the way that you instantiate it is the way that you start any sort of command line client. In the same way that we're running propt, we're giving it arguments itself. Okay, so the arguments we want to give it are netdiv IPv4 address 172.8, and now an IP address that's not the gateway. Of course, the gateway is you can think of it as a router. The unikernel is a client on that router, and it receives a different IP address. And we're statically setting this here. So netdiv IPv4, and then 8. We want to set the gateway. We want to set netdiv, and we want to set the netmask. I think it's IPv4 subnet mask. It was 255, 255, 255, and that's because we are only incrementing the last one. So the last one goes between sort of 0 and 255. So I'm just going to check this correct. IPv4 gateway address. Yeah. Okay. Cool. So when we boot now, it should tell us that we have an interface. Come on, that's great. So we didn't have that before. The LWIP library was able to actually understand that there was a networking interface attached to it, and that it actually has an IP address. So let's split this terminal. Let's quickly find out this one. Okay, so now on the same sort of Docker image as this, I'll get into a second. And we should be able to ping the IP address that we gave it sort of statically, right? So we gave it this is weirdly cleared up, but let's just ping it. So ping 172.88.0. The ping is not installed. Wow, okay. I think it's in details, right? Everyone know it offhand. iNet details. Hey, that's the one. Cool. Okay. Great. Ping it. 172.88.2. Okay. Weird. Oh, whoops. That doesn't seem right.
If it worked, if I recall, it should provide the IP address when you boot it. So
Really?
yeah, I mean that's how it works on my side.
Okay.
What was the command that you used? Was it craft or is used for booting?
I used craft. I used this one, but we.
Yeah, minus minus at the end. Space minus minus. Yeah, it's a weird stuff, but that's has to, you see now
Oh,
how
right,
it
yeah.
works. Space minus
Yeah.
minus.
Cool. Yeah. So there we go. So that looks correct now.
Yeah, now it should work.
Yeah.
Yep.
Cool. Awesome. So you can see it's sending a reply now.
So recall that space minus minus thing at the end.
So, what is space minus minus? Space minus minus is these minuses separate the beginning of a parsing of arguments that is given to the kernel versus the ones that are given to the application. So these arguments are parsed by Unicraft, and everything afterwards is passed to the unikernel itself in the same way that you have, again, command line arguments to an application. So if you think of this unikernel application as potentially having like a help page, just like you have proc-h or any git h whatever, you have, well, in this case it doesn't have dash h, maybe ping has h. Okay, well, like help. Okay, there we go. So you have, it would be the same here, right? This would be then parsed to the application, like actually the HTTP reply one, whereas the first part would be provided to Unicraft itself. So this is like the simple way of running a application on Unicraft using craft run. Underneath the hood, Craft uses a tool called QEMU system x86, which is extracted via the QEMU guest command. QEMU is a virtual machine monitor. It is able to talk KVM on our behalf. It's able to tell us what we want to instantiate to KVM. So if we have a unikernel, an image, it is able to say, here's the image, here's how much memory you want to give it, etc., etc. So Craft can do some of this. So if we run and do some of this, where we can say, okay, look, I want to give it so much memory, -m. I want to give it a particular core. Maybe you have a multi-core system and you want to pin it to this core. The core should only do one thing, and that's the virtual machine itself, the Unicraft unikernel. You can do this here, but you can also use the QEMU guest command, which ships with Craft. And it has a lot more options for a lot more advanced use cases. I will give you a very basic oversight into this to run the exact same thing that we ran before, but with the QEMU guest command. So we can delete basically the Craft run and run QEMU guest. Now, Craft is a little bit intelligent. It tries to figure things out on your behalf. QEMU guest is not, and you must explicitly tell it where the unikernel is. The unikernel, if you recall, is inside the build folder. So we have the HTTP reply program here. DAP-B is the same. We then have -a. This is the argument, the append that you add to the kernel, and this is the same thing here. So this should hopefully do exactly the same. It's booted, it's running on the right IP address, and it's listening. So that's great, and we should still be able to go and see that it is actually talking to us and sending replies. So that's great. Cool. So what did we cover? We covered retrieving remote applications. We covered listing them, seeing what we have on our system. You can now know which ones are installed, which ones are retrieved. If you want to add more, how to pull those individually. We covered how to configure your application based on certain requirements, whether that's a specific option inside of the unikernel itself or whether to add an additional library. And we covered building and we covered running. I don't know if there's anything else that we should cover with Craft itself. I can now maybe use this opportunity to go into a little bit more detail of how Craft uses the relative files of the application and the library to actually configure itself and to run and to build. So let's start diving into the source code, and let's look into HTTP reply. So we've covered how craft YAML file is used by Craft, in fact, to create and configure and build and to run the application. But there are a number of additional auxiliary files that are really intrinsic to the whole Unicraft construction, system, right? And this includes the makefile.uk. Makefile, if you're familiar with make. Make is a system where you have you create something called a directed acyclic graph, where you say, I have a target and it has dependencies. Here we have created a list of dependencies in this variable. This variable is the name of the application plus the directory plus the file. We are going to compile main.c. At the top of every single makefile.uk, we have a little bit of preamble, which basically tells the Unicraft system what this makefile.uk is intending to do. In this case, it's intending to add a new library. It's an app library. It's called app HTTP reply. And we give it this name here. And as you can see, as it highlights, it propagates the rest of the way through this file. So we have the name of this library, or this application, and it has the name plus underscore sources, y for yes, so that y equals in the .config before, the base, which is just this directory, plus the path of the location of the file that we wish, in which case this is main.c, and this is its file here. So this is one of the most important files to actually compile new C files or Go files or Rust files or anything that you want to basically compile into Unicraft unikernel, compatible with its build system, of course. Now, for libraries, which an application, you can think of it as a little bit the same, simply because they are all built in the same way. We have a makefile. This one is a little bit more complex. It also starts with some preamble at the top, saying that we should add this library, but it also has some additional information saying, okay, look, this is a remote library. This is something that we can download and we can patch, and we can include the source codes of it. And when we do that, when we've downloaded it, we can include the relevant source files. You can see it's extracted, and then we get the relevant source files here. Okay, so we have a makefile.uk. We also have another intrinsic file as part of the build system of a Unicraft unikernel. So every library comes with a config.uk file. This is a kconfig file. If you've ever experimented with the Linux kernel or dbtk or things like this, they basically come with a configuration system that's based on this schema. And it provides menu configs. So we have an option for LWIP here. This is the lightweight IP TCP stack. It has a number of things that we can set, whether they are Boolean, whether they are integer values, whether they we have different dependencies. So if we enable threads, we must select all these dependencies to make threading work. This file is read by the Unicraft build system, and it, of course, is read by the menu config application. And when we do this, we open it up, it is able to generate this wonderful menu that we see here today. And if we go into it, you see that there is a new option right at the bottom, lightweight TCP IP stack, where it has all these additional options, where it is, you can select things,
Alex, sorry for intervening. I think these are some topics that we're going to cover tomorrow, because we have the behind the scenes session as well. So I wouldn't go that much into that part for two reasons. One of them is that we're going to cover kind of each of those, kind of kconfig and the others tomorrow. And the first, not to be too much for the participants. So maybe we can just go faster on this topic, and we can do a more profound discussion tomorrow.
Sure, no problem. I mean, the main reason I wanted to get into this is that there are two main files that we must be aware of inside of the Unicraft build system. Because if we want to use the make menu config system within Unicraft itself, without the use of Craft, we have to be aware of the make system itself here. So with the Hello World application, we have a make file that points to these relevant directories and reads these relevant files. And so we can use the same make menu config system and the same make system to build the same application. So if I go into Hello World, if you do not wish to use Craft, then there are a number of reasons why you might not wish to use Craft. It might provide you a lot more extensibility, programmability, etc. But in any case, if you do want to go this route, you can use a makefile, and you can call these relevant files from the makefile. So with this directives acyclic graph, we have a dependency and we have a target. So we have all. So if we type make and all, we will reach to this particular entry point here, which calls make at the root of the Unicraft build system, which is this build system here. So it calls the make directory here. It starts reading all the makefile.uk's. It starts reading all the config.uk's. It also reads any additional libraries. So if we write make all, we are again, maybe make clean. Yeah. So again, make, and it's calling either all, which we set here, or anything that we have passed to it. So if I type any, literally anything, this is what this means. It then goes to the Unicraft core and then passes anything. It should actually just show this is nonsense and doesn't understand it. But if we type make help, it will go to the make Unicraft make system and it will provide us a number of different objects that we can then call. So we had make clean, which removed all the build objects, it deleted it. We can do make proper clean, which will delete the build directory. But because I run make clean, I can then run make again. Without Craft, I'm able to build all the files again. The caveat to this system is that you must introduce this make file for every application that you build. So the Hello World application comes with a little bit of a boilerplate make file. You'll see in the HTTP reply application that it does not come with a make file. It comes with a makefile.uk, which is again an interesting file that Razvan has very accurately said. We'll get into more detail. But if we want to use the make system, we have to make a new makefile. And so we can do that. Now, the makefile is also very explicit. It requires you to tell it, first of all, where the paths are for the Unicraft core, which it's downloaded when we use Craft, where the list of the libraries are available to us. This is, in this case, it's this directory here, up 2 directories and then down. But we also need to tell it which libraries we wish to use. So if we want to have an additional library inside of this particular application, we must write it in this list here. So we must do UK libs lweb. This is the list of libraries that is needed for HTTP reply to work. So now if I go to HTTP reply, I have the additional makefile. I can then just do make clean, because it will propagate that command via this make summon goal. And then I can do make again, and it should just build it as is before, the same way that Craft does it. Because Craft inherently just calls this command underneath the hood, but is able to intelligently figure out which libraries are required and where it will retrieve them from, etc. And eventually, once it's built the core, you'll see that it eventually builds lweb. If you do not include this line here, it will not build lweb. Yeah, I think this covers most of the basics for getting started today and how you yourself can use the Unicraft toolchain to build your own unikernel. I want to very quickly go over a quick tip that I use a lot to get started building unikernels, and that's to basically use Docker. Docker is a completely different way of doing application isolation. It creates a virtual environment for you that you can use to, yes, build applications, to run applications, but for us, it provides us a really nice build environment that has everything that's installed. And we ship with Craft a Docker environment that contains all the build tools, all the right scripts, etc., in a relatively clean environment where you can basically get started very quickly. So if you have Docker installed on your machine, you're comfortable using Docker, you can use it to basically build unikernels. You can even run unikernels via Docker. Now, it's important to make the distinction between a container and a virtual machine. A container is OS level virtualization, whereas a unikernel is hypervisor level. It runs on the hardware quite directly, whereas the container basically provides OS level isolation. It runs as a process or multiple processes. It creates a file system that we can then use and retrieve and work to our basically to all our needs. So whilst we can build things, we can also run things, and we can run things because we mount paths that are within the unikernel, within the operating system, the host operating system. What you see here, this terminal here is my host operating system. It is running Linux, and you know, I can install whatever I want on it. You know, I think I am root. Anyway, if we mount the paths that are for talking KVM and QEMU to the Docker container, then inside the Docker container, we can then actually run unikernels. So how do we do that? Okay, so if you have Docker installed, and actually you can use other tools like Podman or whatever, but Docker is the sort of industry standard. You can do Docker run -IT for interactive terminal. So -I is literally interactive, T is open up a terminal. I always do --remove. --remove basically removes the container once it has exited. So when I type exit, I want the virtual file system the temporary virtual file system to kind of be deleted. This can be a caveat, but the way to circumvent this is to mount the correct paths. So you can do this by setting a volume, so -B. So if we want to save what we are building, we mount a path that's on our host into the container. That means that once we're inside the container, we're actually dealing with a folder that's actually on our file system. So the way to do this is, let's go, so Docker run it move. So we can open up PWD. This is the current path, and then the place to mount it always is inside of user, SRC, and then Unicraft. This is the default locations, the workspace that is provided inside the container environment for the Unicraft, sort of the official Unicraft craft container. We can do the workspace is this same directory, and then the entry point is bash. So this is the shell that we'll be using. You can customize the container and you can change the shell if you would like, or you can mount your current shell. Bash is fine. Now we then set the name of the image that we would like to use, and this is unicraft/staging. So it goes to the full path is docker.io/unicraft, but by default, if you're using Docker, you can omit this place. When we launch this container environment, we then have craft installed, right? You don't have to install all the dependencies. It will download this image if you've never downloaded it before. It will run, it will pull all the relevant file system layers, and then it will mount it, and then you can do craft list update, and it should be able to work no problem. Bear in mind that you must set, again, when you initialize your environment, the craft token, right? The token that you use for GitHub. You must set this. You must either do export or whatever, right? So export UK, I think it's craft, what's it again? Quickly scanning the tutorial. Yeah, it's just craft GitHub. Right, you set this with that environmental, you set the environmental variable with the token that you retrieve from that URL. Then you can access the remote repositories. So this is what I jumped into before. And this is what I'm pretty much always working. And if you always pull the latest version, you get updates of craft as well, without having to reinstall craft itself through pip. This is quite a nice environment. It's quite stable. It has everything that you need to work. But if you don't, so this is great. This is great for building and for getting started. For the ability to be able to run unikernels via Docker, you must mount an additional path. You must say device dev KVM, or at least for KVM, right? So I've never tried this on Zen, but for KVM you do --device you set the path, device KVM. This is a Unix socket interface. When you mount this, the kernel, the Docker image then has this sort of in the same place, and the can use system command can work in command. I think this covers everything. I think we're also just about out of time. And I think we'll take it from there.
Yeah, thank you so much, Alex, for the. This part of using Docker, this is something we should also add to the actual session, because it's useful info. You have this kind of stable, all-in-one place environment. So we're definitely going to add that to the session as well.
Yeah, no problem.
Yeah. So going forward. Yeah, please, Alex.
No, thank you for listening.
Yeah. If there are any sort of questions from your side, this is the time to ask them. Otherwise, I think we can move ahead with the team splitting. Christy, Alex, and Vlad are going to be the trainers. Christy, I think you have the team split, and then if I recall, they're already assigned to teams, so maybe you can share a bit of info on that.
Yeah, the teams were made before, but I saw that some people are missing, so I remade the teams. I will post now the teams.
Okay, so basically then
general.
Each person is then going to see their own channel, right?
Yeah, if you look in the left menu of Discord, you have USOC team choosing, where you must react with the number of your team, A being 10, B 11, C 12, because we ran out of numbers, and then you will have access to the team channels, one for text, one for voice.
Awesome. So everyone, please go to your teams and open up. We're going to give you the link to the first session. You have the 4 tasks, but what we recommend is you also go through the 2 kind of tutorial tasks, the one on Hello World and on HTTP reply, just to make sure you are able to reproduce those steps that were demonstrated by Alex earlier. So even if they are not marketed as kind of practice work, do go through the first 0, I think it's called 00 Hello World, or 01 HTTP reply, or something like that. As part of the session, there are tutorials. They give you all the hints, just to make sure you cover all the tracks. And when you go to the teams, when you have any sort of issue, discuss among yourself, provide support, ask either on the team channel or on the general channel for support or for help. And Alex, Vlad, and Christy will come back to you with additional information. Says it all. Have fun, and let's get crafting.